So next we're going to look at complementary angles. So you've learned this concept before about complementary angles when mainly been dealing with right triangles. So the idea being, if you have a right triangle, you know that one of your angles is obviously 90 degrees. So if you were to refer to, let's say, one of your angles as theta or x, whatever, you know that the other angle would be complementary to it, which means that it would be that the two angles would have to add up to make 90. So the other angle, we would know if both of these angles have to add up to be 90, we would call it 90 minus theta or 90 minus x. And so, because when we add those two things together, we would get 90 degrees. So what would that look like on a unit circle, or on when we're dealing with rotations instead of just set triangles? Well, if we were to rotate, let's say 90 degrees, or excuse me, let's say if we were to rotate theta, so this type of angle here, its complement would be 90 minus theta. So we take that same distance away from our 90 degrees, or pi, and we create 90 minus theta. So there are certain things about angles that are complementary that we can say for sure, based on the symmetry of how our unit circle works and how the symmetry of the trigonometric functions in general. So we're going to discuss that here in just a second. So if we were to look at this in reference to a right triangle, okay, so let's think of this in terms of the right triangle here on the right side. We could label our sides. And now if we're talking about for theta, we could have this would be opposite, this would be our adjacent side, and this would be our hypotenuse. Now, obviously, this would be switched up for for 90 minus theta. So let me remove this quickly. So if we're talking about for theta, obviously the cosine or the cosine of theta is going to be a over h. Okay, sine will be of theta is going to be O over h, and tangent of theta is going to be O over a. Well, how does that change if we're dealing with 90 minus theta? So we have to rethink of, we have to kind of think about it in terms of its own thing. So if we're referencing theta, and if we keep all of these sides the same, so think about these sides because we're referencing this. So for 90 minus theta, if we were to do the cosine of 90 minus theta, okay, cosine would be its adjacent, which would be the opposite. So if we're talking about it, so this would be the opposite over the hypotenuse. Well, notice that these two things are the same. Okay, the cosine of 90 minus theta is actually the same thing as the sine of theta. So the cosine and sine of complementary angles are identical. This is important. So it's just kind of like changing your reference view of a right triangle, or changing your reference on a rotation. You can end up with the same function. We'll learn a little bit more about this when we go to graphing. Now, if we're dealing with the sine of 90 minus theta, so the sine of 90 minus theta deals with its opposite over the hypotenuse. So now this is going to be a over h. So kind of like just what we were saying again, like the sine and cosine of complementary angles are identical. So that's nice. And then when we deal with the tangent of 90 minus theta, or pi over 2 minus theta, that also works. The tangent would be its opposite over its adjacent. So that's going to be a over o. Now, that is the reciprocal here of tangent. We call that the cotangent. So very quickly, I'm going to flip the page and write down the following identities which you'll want to know. So The first one, again, is that the sine of 90 minus theta equals the cosine of theta. We also have the cosine of 90 minus theta, or 90 degrees, more specifically, is going to be the sine of theta. And then we have the tangent of 90 minus theta is going to be the cotangent of theta. So these three things are all true. Mainly, you'll look at these two, and it's very helpful because like as you move around the circle, as you move around the unit circle, if you just go back a certain amount of angles, you actually get the other trig function. It's very, very useful. And it'll make a little bit more sense when we get to the graphs, how to view these two different things. So it all goes back to thinking about a right triangle, but now because we're dealing with angles that can go on forever, that we think about them in terms of rotations and the unit circles. So just keeping all of these things linked is going to be important when we're using trigonometry to help solve problems in the future.